This is Unit 7, particle motion using derivatives and integration. So let's start talking. Let's think about position for a minute where you have an object set. So consider an object moving in a straight line, either horizontally or vertically. For example, a car. Y'all all drive your car down the road, right? As an object moves, its position is a function of time, right? So if you're going down the boulevard and you're next to the high school, in a few minutes, you'll be past Fuzzies. In a few minutes, you'll get to the town square. So as you drive, your car moves. So we're gonna talk about basically with particle motion, everything that happens in reference to time. If you throw a ball up in the air, it comes back down, and you know it'll take so many seconds for that to happen. The symbol for position is either ST or XT. So if you see ST or XT equals some equation, you have to know that they're referring to the position equation, because we're also going to have acceleration and different things and velocity and all that. So you need to recognize S and X as the letters that represent position. Okay, so if you could just write on paper, you don't have to print this. Those mean position. Okay, those are the symbols, the standard symbols for position. Okay, let's think about velocity. As we know, when an object moves, its position changes with time, like from here to Fuzzies. Therefore, we can say velocity is the change of position, right? Therefore, we can denote velocity as a VT. So velocity is VT. I'm going to write it again. Or velocity is a function of position. It is the derivative of position. Now, do you remember back in physics when you only used algebra, how you found velocity? It's much easier in calculus. You just take your position equation, take the derivative, and you now have velocity. Isn't that cool? That's so cool. Another detail we want to talk about is, when does the velocity of an object equal 0? What do we say about an object that velocity equals 0? What do we say about the object? Is it moving or stopped? It's stopped. So the velocity of an object equals 0 when it is stopped. It sounds silly to state that, but we want to start thinking about, in math, we're often looking for zeros. So in your brain, I want you to start thinking about, okay, if an object is stopped, my velocity is 0. I might be able to set things equal to 0 if I know they're stopped. Okay. Basically, if we think about motion, now remember, we're talking about straight line, simple motion, walking forward, walking back, going up, going down. We're not talking about a big curvy roller coaster yet. Okay. So horizontal, that's this way, right? It moves right when velocity is positive. It moves left when velocity is negative, and it's stopped. So when you see negative velocity, you're thinking left. If we're talking about vertical, maybe a bug crawling up the wall, right? That's that direction. It moves up when velocity is positive. A negative velocity means it's moving down, okay? So since velocity is speed, you obviously can't have a negative. Well, it's not exactly speed, but it's how fast you're going in a direction. So it makes sense that you can't have a negative magnitude of speed, right? So in our motion, positive is up or right. Negative means you're moving down or left. Does that make sense? We're not saying you're going back in time. If we could figure that out, we'd be in great shape, right? Okay. Okay, so let's look at some problems. If ST is t squared minus 2t minus 3, where t is measured in seconds and ST is measured in feet, find the object's position at 2 seconds. Right away, when you see ST, what does that refer to? Position, velocity, or acceleration? ST means position. And we've got to read our statements clearly so we know what they're asking for. Like they said, what is the position? So obviously we're going to plug 2 into position, right? So S of 2 equals, what do you get when you plug 2 in? Well, 2 squared, that's 4 minus 3 equals -3 feet, right? You simply plug it in. We don't really need a calculator for something that easy. So this tells you by the negative, it's either moving left or down, right? Okay. Particle moves along the x-axis. Now, if it's moving along the x-axis, we know we're talking right and left, correct? On any time. Now, let me ask you guys this. Is that always going to be true? Is t always greater than or equal to 0? Can you have a negative t? T is time. We can't. If you're able to get negative time, you're going and get a Nobel Prize in physics for that, right? Because we can't. So even if I don't state that, you need to know as a person alive on Earth that time always has to be greater than or equal to 0, right? Can't be negative. So watch that when you do problems. Don't say, you know, t is less than 5. You'd have to say between 0 and 5 because we can't go negative. Okay, so a particle moves along so that its position function, again, we know that x or s means position, is -10 minus 3t plus t squared, where t is measured in seconds and s is measured in feet. What is the particle's displacement for the first 5 seconds? In your mind, how do you think you find displacement? What does that mean? Means how far away is it from where it started? If I'm at my desk and I walk to the door, what's my displacement? How far did I go? What do you think the formula is? Simply the end value minus what? The beginning. So if it's the first 5 seconds, we're going to say S of 5 minus S of, what's my beginning time if they don't state otherwise? 0, right? If they wanted me to say between 3 and 5 seconds, they would have had to tell me that. If they don't tell you a start time, we're going to start at 0. Okay, so plug that in and let me know what you get. 5. It's -5. Or -10 minus 15 is -25. Oh, that's 0. If you plug a 0 in, we get -10 equals, right? Now, let me ask you something. This next question looks very similar to me. And all I did was plug these into the equation, right? What is the particle's total distance for 5 seconds? Is total distance the same as displacement? No. So let's kind of sketch this out for a second. Let me do my desk and the door, right? If I go to the door, that's my displacement. How far away am I from the beginning? But is it possible, I'm going to do displacement in this color. If I start at my desk and I walk here and I'm like, oh no, I forgot to get the pencil I was going to sharpen. So I walk back to my desk and then I go to the door. Is my displacement the same in both of these examples? Yes. Is my total distance different? Yes, because I had to walk back. So I walked further than I did here. How do we address that? Let's think about it for a second. I'm definitely going to have a start and a stop that are the same as these two things I figured out. But if I'm walking this direction and I have to turn around and go this direction, what do you have to do? If I'm walking in a straight line and I want to go backwards, what do I have to do in order to start going backwards? Before I can go backwards, I have to look at my pen. Okay, if I'm going this way and I go backwards, what does my pen have to do to go backwards?
Stop.
It's got to stop, yes. So how do we find the total distance? Well, we check where we start, time 0, and then the first 5 seconds where I end. What do I need to check in here? Any stops. Okay, I have to check any stops because where I stopped, I could have turned around. I might not, but I might. My math will tell me that. So how do I know where an object stops? I've got this equation right here. How do you think I know where that stops? What did you write down on the first page? When does the velocity of an object equal 0? When it's stopped. So stops where velocity equals 0. So I'm going to have to find out where velocity equals 0. So I'm going to set velocity equal to 0. Where am I going to get a velocity equation? They gave me position. Where do I find velocity? Well, let's see what we wrote down on the back page. What did we say right here? Velocity is what? The derivative of position. So what is velocity? What's the derivative of this equation? -3 plus 2t. Right? I just used my power rule, so -3 plus 2t. So remember, that's s. And now I'll set that equal to 0. Okay? Does that make sense? 3/2, you can put 3/2 in here or 1.5. Either way, I like 1.5. We don't ever speak of 3/2 of a second, do we? We'd say 1.5 seconds. So we already plugged 0 in. What do you get when you plug 0 in? We already got that, -10. We saw it up here. We already plugged 5 in. So now take 1.5 and plug it into this equation, and you can use your calculator. By the way, you can have your calculator for this whole chapter. Plug 1.5 in. Now, what does this say up here? Your notation is going to be vital in this unit. So this says ST, correct? So you've got to take this and plug into ST. So plug that into ST and figure out what that is. What is it? Somebody tell me, plug it in, get your calculator or your phone. Anybody? Come on, come on. Try it with your own fingers. This is what I got. But actually type it in. If you just copy what I have and you haven't typed it in, you might not know. So we kind of right here. Must see where it stops. Anytime an object stops, let's think about this now. An object is moving. Anytime it stops, it could either keep going and it might not change my distance, or if it stopped, it could go back the other way. So that's what we're checking for. Everybody get that? I'm relying on y'all to check my work. My typing's not too good, you know that. Okay, so now what you have to ask yourself is how far apart are these numbers? How far apart are -10 and -12.25? How far apart are they? 2.25, right? True? Now, how far apart are -12.25 and 0? Those are 12.25. Notice I'm not going to have negative numbers over here because I'm asking what? How far apart? So I'm not going to say a negative number. I want to know how far you walked. So if I went this far and this far, what's my total distance? I'm going to add these up, right? And I'm going to get 14.5. So we're right now using the derivative to figure out how far we went. We will have another way to address that gets even more accurate when we practice our integration with these. But for right now, this is a pretty good way. Is everybody okay with that? These are the two things that people get mixed up when it comes time for a test. So let's make sure you know. Displacement is n minus beginning. Total distance, we do the beginning and the end, and then we check any stops along the way to see if he turned around. Okay? All right. Is speed velocity? Are they the same thing? No. You know that from physics. Speed can never be negative, therefore they're not the same. We write speed as the absolute value of velocity. Velocity is speed and direction. So your number for speed and velocity are going to be the same. If the velocity is 5, the speed is 5. If the velocity is -5, the speed is 5, right? And y'all are familiar with that with your car. Speed has to be positive. Speed is how fast you're going. Velocity is how fast are you going and what direction. So velocity is negative. For us, it means I'm going that same size of speed, but I'm going left or down. Does that make sense? Right? Not so bad. Okay. Example 3. Remember, what does xt stand for? I want you to think of a word when you see the x versus x sub t. What does that mean? Position. That means where your object or your particle is located. So here's the position. T is in seconds. Find the velocity at 2 seconds. All right, I've got position. Therefore, I know velocity, don't I? What is velocity? Let's write it down. Velocity. Remember, you remember what you write. If you're typing all your notes, I highly recommend you get a piece of paper and write this stuff down. Research is still showing that when you write with your hand and a pen, it puts it in your brain differently and you retain it. Plus, if you're going to do homework or a test, don't you want a piece of paper written down and not have to toggle? So velocity is the derivative of position. So if you have a function for position, do you have a function for velocity? Yes. So what is velocity? Here's our position. It's what? -6 plus 2t. Can you write 2t minus 6 if you want? Sure. What is the object's velocity at 2 seconds? So you're going to say velocity of 2. So you're going to plug that in. So -2, and remember you want to write feet per second. This is a velocity. Therefore, what is the speed? Velocity is -2 feet per second. What is speed? Speed equals 2 feet per second. And it's not negative. If you answer a question on a test, a quiz, or anything, and you say speed is negative, you can't have credit for that, even if you have the right number. You must always make the transition to a positive number for speed. In what direction is the object moving? Because we have a negative sign here, it's either moving left or down. It did not tell me if it was traveling on the x-axis. I don't know if this is a bug crawling up the wall or something running back and forth. Let's think about acceleration. So acceleration is the change in velocity over time. So acceleration is the first derivative of velocity. What's another way that I could say the derivative of velocity? The second derivative of position. So let me ask you this. If you have a position function, do you know velocity and acceleration both? Yes. And I like to think about it like this. You've got position. If you take a derivative, you then have velocity. And if you take the derivative again, you then have acceleration. I like you to think about them like this, because what's going to happen? You have position and you can go to velocity and acceleration in a couple days. I might give you acceleration and go back up. So I think this visual image of kind of going down, because when you think of a derivative, what do you think about? This is big picture, y'all. When you think of a derivative, what do you think with your powers? Down. So as you take a derivative, you go down. So what does that mean later when I give you acceleration? How are you going to get back up to position? What are you going to do? If you took a derivative to go down, what are you going to do to go back up? Integrate, right? See how that works? So I really like you to think about them that way. Okay. When an object's acceleration is 0, does that mean the object is stopped? Now, if velocity is 0, it's stopped. If acceleration is 0, is an object stopped? No. It just means it's at a constant speed. What does your car have that keeps your acceleration at 0? What do you like to put on your car when you're on a long road trip? Let that sink in for a second. If you're traveling at 50 miles per hour constantly, your cruise control's on, you're not accelerating anymore, right? You just have a velocity. Now you've learned in physics, let's keep these straight. If your speed is, or your velocity is 50 miles an hour, since it's velocity, your acceleration is 0 because your velocity is constant. Now, if I say your speed is 50 miles an hour and you change direction, then you've also accelerated because velocity changed, right? Remember that from physics. It's not just the speed that changes. You could change direction to change your velocity. Any questions so far? Or is this feeling like this is going to be way easier than physics with algebra, right? Okay. Let's try a problem. Given that a particle is moving along a horizontal line, so that means it's going either left or right, correct? The position function is this, where t is in seconds, st is in feet, or position is in feet. So what's the position function? I'm making you write this several times because I want you to for sure see that st is position. So now what's velocity? What's your velocity function? You take the derivative. So what is velocity? 2t minus 4. And then what is acceleration? Acceleration is the derivative velocity. So what's acceleration? Derivative of this is just 2. Are we good? Does this make sense? If you have position, you take the derivative to find velocity, and then you take the derivative again to find acceleration. So if you're given position, can you find the other two with no additional information? You can, right? The equations. Okay. Are we ready? Are we good? Y'all have to answer in class because I can't see the people at home. They're all just letters. It's my Scrabble game. So if y'all get it, the people at home have to get it. All right. What are the graphs? If you look at these equations up here, what do the graphs look like? I want you to notice something for your, it's for a future chapter really, but I know that that's at 2, so I know there's position. What does velocity look like? Right? And then what does acceleration look like? I'm foreshadowing right now. We will have a curve sketching unit where you tell me what velocity is going to look like. But notice how the curve comes down a power each time, right? We'll get into reading this, so I just kind of want to foreshadow. All right. What's the object's displacement after 3 seconds? How do you find displacement? What is it? S end minus what? S beginning. So y'all figure that out. So 3 seconds. So that means I'm going to find S of 3 minus S of 0. It's very important for you to write this notation down so that the whole big thing. So someone find me an answer. If your name starts with M, you got to answer me. That leaves me 4 people at home. Let's see if the M's can do it this time. Which M can be first? Go. M's. Anybody? Anybody got it? What's S of 3? What do you get when you plug 3 in here? Did you get negative 1? So 9 minus 12 is 3. Negative 3 plus 2 is negative 1, right? Yes. Negative 2 or 2? 2. Okay. So that equals what? What does the negative mean here? Since this is going horizontally, this means it went left 3 feet, right? Where is the object stopped? Well, where VT equals 0, right? So I'm going to say 0 equals 2t minus 4, 4 equals 2t, t equals 2, right? So at 2 seconds. Now, how do you think we figure out if it's moving right or left? Where would the object be moving right or left? We simply do a little chart, right? Now, of course, time starts at 0. And what do I know about 2 seconds? It's stopped, right? So I'm going to put a 2 on there. So now we'll try a number. What's a number between 0 and 2? 1. What's a number bigger than 2? 3. So put 1 into your equation for velocity, right? What kind of an answer? Is that positive or negative? Right? So this is negative. Now what happens when we plug a 3 into velocity? Right? Do you see what we did? These numbers are not part of your chart. It's just what you're plugging in your head. So where this is negative, it's going left. Where this is positive, it's going right. This is going to be a skill that you use over and over again. Very important, big concept. So it's moving right, correct? You could say t is greater than 2 or 2 to infinity. You can't use a bracket because at 2, it's actually stopped, right? Where is it moving left? It's moving left from 0 to 2. Or what else could we say? T, well, let me say this. Right? You could say when t is between 0 and 2, and you might see it just written t is less than 2. I would accept that, but I want to make sure you know that when we say t is less than 2, we never go past 0, right? Is everybody good with that? You never go past 0 with your time. You can't have negative time. Is that okay? All right. The next question, when is the acceleration 0? So acceleration equals 2. Is there a variable here? Is there a variable with that 2? No. So if it 2, it's always positive because 2 is a positive number. Never equals 0. Can't set 2 equal to 0, right? No variable. So I want y'all to notice that in your math problems. If you have a number and there's no variable with it, you can't change it, right? It is what it is. It's just 2. So now how can we tell if an object is slowing down or speeding up? It's slowing down if velocity and acceleration have different signs. It's speeding up when velocity and acceleration have same sign. So you've got to do a sign chart for both of those. So I'm going to do acceleration. Again, I don't like to put an arrow on the left side because time never goes past 0, right? And I'm going to do velocity. Again, I like mine color coded. This pink keeps pulling me to velocity. Now, what did you figure out about velocity at 2 seconds? So velocity was negative and then positive, correct? And what sign did acceleration have the entire time? Acceleration never changed sign in this particular problem. So right here, we are speeding up because they have the same sign, correct? And right here, we are slowing down. So you may want to highlight. It makes it very easy for your eyes to see that. So slowing, where is it slowing down? From 0 to 2 seconds. And where is it speeding up? From 2 to infinity. Now, why don't we have a bracket here? At 2, it stopped, so it's not slowing down or speeding up. We're almost done, y'all. We don't have much to do. All right. Does this make sense? All right. So I'm going to pause this recording for a second. You've had a few minutes to look at this, so let's go over it together. See, you can watch and see if your work matches. So what is a position function? So it's just t cubed minus 8t squared plus 9t plus 18. What's my velocity in this one? Just take the derivative, right? 3t squared minus 16t plus 9. And what is acceleration? Right? 6t minus 16. Any trouble pulling the 3 equations out? That's easy, right? Now, if you see where is the particle, where it is going to be a position function. So at 2 seconds, we're going to say s of 2 equals. And what do you get when you plug 2 in there? That's what 8 minus 2 squared is 4 times 32 plus 18 plus 18. And what do you get there? 24, 6, 18. You get 12? Okay. So 12 feet, right? What is the particle's velocity? So we're going to do v of 2, and that's 2 squared is 4 times 3. What is that? 12 minus 32 plus 9. What is 12 minus 32 plus 9? Negative 11? So this is what? We don't know if this one's on the x-axis or not, so it's either 11 feet left or down, right? When does the particle change direction? It changes when velocity equals 0. So we are going to have to factor that. And what do you get when you factor this? Or actually, I don't think this factors, does it? So we're going to use a calculator. What do you get when you plug that in? Does that factor? I could do a 9, 12. So if I do a 3 and a 3, that's 9 and 3. Okay, won't factor. So what did y'all get for T? Do you want me to go through that with you? Are you comfortable getting the zeros out of your calculator? Okay, so see if you got what I got. I got 0.639 and 4.694. Does anyone need me to pull the calculator out and go over how to find zeros with you? I'm happy to do it. And you can do it.
Oh.
Yes.
Yeah, you go through it, please.
I will. This is
Thank you.
very important. Don't be shy, because if you can't do it, we're in big trouble for a long time. Whoops. Let me get rid of the polar graphs unless y'all want to review that. Okay, so we're going to type in 3. Now your calculator doesn't care if you have the letter X, correct? Okay, did I type it in right? So let me show you the best, fastest, most efficient way to do this. You're going to hit graph. And we're looking for the zeros. So we need this dot and this dot. So you're going to go second, calc, 0. Now it says left bound. What you have to tell your calculator is a number on the left and the number on the right. So you could see zeros on the left of this intersection. So 0. And you can see that 2 is on the right. So 2, enter. Then it will say guess, and you hit enter. And it's 0.6390. Now we need to find the other one. So you have to do it again. You're going to go second, calc, 0. Now let's look at this one. 1, 2. This intersection here is between 3 and 7, right? You could get tighter, but I'm just going to pick any number right here. So I'm going to pick 3 is on the left side. See how it puts a little line up? Then I'm going to say 7's on the right side. Do you see how your calculator put lines in? That means it's going to look for a 0 between those two boundaries. And then you hit enter and you've got the other one. Is that okay for everyone? Did that help? Very important skill. Okay. Okay. When is the particle speeding up and slowing down? So I'm going to have to check velocity, right? Here's velocity. And I'm going to have to check acceleration. Now, I need to know where it stops. Where does this thing stop? Do I know yet? Have we figured out where it stops? We have. Where does it stop? It stops where it changes directions, right? So I can already put my velocity on. So 0.639 and 4.694, right? Got to put those on. So now you need to check. Now you could do this by looking at your graph. Let's go back. Now, over here between 0 and between where x equals 0 and where x equals 0.639, is the graph positive or negative? It's above the x-axis, right? So you know this is positive. Now between the zeros, the curve is below the x-axis, so you know that's negative. And then after this, you know it's positive. Do you see how you can easily read that with your calculator? Right? Positive, negative, positive. Okay, now we have to do acceleration. Acceleration is 6t minus 16. That's easier to find. We don't need a calculator. So t equals 16 over 6. I will see what that decimal is, right? So 16 divided by 6 is 2.667. Now make sure these are scaled alike. So if this is 0.6 and this is about 4, we want to make sure we don't set this 2 to be bigger than that 4. So now we need to check either side. So if you look at this, if you plug 1 in for t, you're going to get a negative number. So we know that's negative. And if you plug a big number in for t here, 3, 4, 5, you know it's going to be positive, right? And I like to make a whole bunch of little signs so I can see, because what am I looking for? Okay, so speeding up, I'm going to color yellow. That's where my signs match. So right here, my signs match, and right here, they match, correct? And then if you look here, this little strip here, velocity is positive, but acceleration's negative. Make sure that you see what I'm seeing, where they're speeding up and slowing down. Do you see how you need to scale things so that 2 at least fits in between those and they need to be the same? All right, so where are we speeding up versus slowing down? Okay, where are we speeding up? Wherever it's yellow. So that is 0.639 to 2.667, right? And 4.694 to infinity. Now, why do I have parentheses and not brackets? Because what happens at these two numbers? Is it speeding up at the 0.639 or the 4.694? No, that's where the thing is stopped, right? And where is it slowing down, right? 0 to 0.639 and 2.667 to 4.694. Is that okay? Do you see how a highlight can really help you see these differences? I think it's very easy. And this is why instead of just putting one big negative sign there, I draw a whole bunch so that as I highlight, I can see where things are positive and negative. That's my preference. That's not a hard and fast rule. Are you okay with this? Can you repeat that on homework? Okay, you got a good thing to look at. One last little vocabulary word I want to bring in for you, and that's average. So what does the word average mean to you? If I say average your grades, what will you do? You'll add them up. If you have 5 grades, you add them all up and divide by 5. So average means you've got to add something up and divide, right? True? So average velocity uses 2 data points. You take the first and the last, and then average them, right? Average acceleration uses 2 points. What does the word instantaneous mean to you? What does that vocabulary word mean in general? Where are my English majors? What does instantaneous mean? Means right now, right at that moment, right? So instantaneous means you only use 1 data point. Meaning if I want to know what's the instantaneous speed right now at 2 seconds, then I just plug 2 in and I'm done. If I need average, I need to take the beginning and the end and average, right? So if you drove to Austin tomorrow and I said, at Waco, how fast were you going? And you're like, I was going 80. That's instantaneous right there. If we take how far it is and how much time it took, it gives you an average. I just came home from Denver. My average miles per gallon was 27.6. Was I getting 27.6 the whole way? No. When I was passing cars, I was getting 10 miles to the gallon. When I was going down a hill and I hit the brake and I wasn't doing anything, I was getting 99 miles per gallon, right? So the average takes into account your whole trip and how many gallons of gas you used. So think about that with average and instantaneous, right? Now, average velocity is your change in position over t. Your instantaneous velocity, we just plug into t. So remember, average, and I'll give you how I remember that. Average acceleration is the change in velocity over t. Instantaneous, you just plug into acceleration. Now, I want you to think about something. How did I tell you to remember the order of these things? We have position, velocity, and acceleration, correct? Now, let me ask you guys something. No matter what your average is right now, right? No matter what your average is, would you like your average to go up or down? Up. We always want our average to go up, correct? So look at this with me now, really look. If I want average velocity, what did we say we wanted average to do? Go up. And if you go up from velocity, where are you? Position. So it uses the position thing, right? If I said, what's your average right now? It's just average. If I said, what's average acceleration? The word average means go up. So for average acceleration, you got to go up and use velocity. Make sense? And that uses velocity divided by time. Instantaneous, you just use whatever they asked you. This is a good way to remember them. We're going to have a lot of formulas by the end, and it really helps you to know what you're looking at. Okay, let's try this. Given this equation, T is in seconds, S is in meters. Find these things. What's the position function? Okay, we know how to find that, right? Why do I keep asking you that again? So you know position means to use that one. What is velocity? It's the derivative. And what is acceleration? The derivative. Any question? What did I do? Oh, that's a cube. Oh my gosh. 6t squared minus 4. Okay, that's better. And this is then going to be 12t. I forgot my cube. Okay. Any question about how we get those equations? Okay. Find the average velocity for the first 3 seconds. Where do you want your average to go again? Up. So we go up from velocity and use position. So that's going to be S of 3 because it says 3 seconds. So that's where the 3 came from. Now, how many seconds do you get from 0 to 3? 3. Right? Find the velocity at t. You're just going to do v of 3. I'm going to set these up and I'll let y'all plug them in. Find the average acceleration. Where do you want your average to go? Up. And what's up from acceleration? Velocity. So that's going to be time. Time is 3 seconds, right? And acceleration, if it doesn't have the word average, they mean instantaneous. So you just find that. So take a second and figure those out. What do you think? Is that easy? This is it. That's all we have. Hurry, come on. All right, so that's 42 minus 0 over 3, which equals 14 meters per second. If I just plug 3 into velocity, right, that's 54 minus 4 equals 50. Here I'm going in, so that's what? What's V of 3? 50 minus negative 4. Now, remember acceleration is meters per second squared because it's changing velocity and time. So you got 2 times in there. And this is that. So that's what, 36? Any question over these? If you have your notes, can you do it? Is everybody realizing that position goes to velocity, which goes to acceleration? You take the derivative to get down there. Of course, in a few days, we're going to go backwards and go up, and then we'll integrate to go from acceleration back. But okay, so you have, that's it. No more notes. You are done. So do today's homework number 1. It's in class kick. I'll meet you there right now.